First we'll talk about, what does a good architecture mean? What represents as a good architecture? We'll look into different architectural frameworks and look at what a typical architecture stack looks like. And then we can get into what do we mean by conceptual and software architecture. We'll obviously look at some examples. And then lastly, the most important question is, all this is great, but how does this apply to the competition, and how can we use all this? So that's essentially what we're going to try and cover in the next hour and a half. We'll leave some time for questions, and that way, hopefully we can try and address a lot of things that is going to come into your next phase of delivery. All right, so let's get started. Okay. So what is a good architecture? I mean, there are different definitions of what an architecture is. There are, people have written about architecture. People have thought about, what constitutes, or what is the thing that we're trying to this. But rather than going into definitions and such, let's look at what should a good architecture take into consideration. What should a good architecture look like? First of all, the basic purpose of any architecture, software architecture is, or any IT architecture is, to address a business concern. The whole purpose of doing any of this work is to make sure that we are addressing the functional requirement, what the business needs. That's really the whole goal. It takes into consideration of what the technical requirements are. What are the things that our organization already has? What are the things what are the components, technical components that we're going to need to build that architecture? And it also addresses the architectural concerns. And we can look at what the architectural concerns are and what it means. But essentially, it's trying to build a solution using the technical components or using some technical components, and also making sure that we're addressing what the architectural concerns are. An architecture should also take into account what the organization dependencies and risk are. Any organization already has legacy system. They've got things in place that you either want to reuse or want to make sure that you address. There are some organizations, which have PII data or HIPAA data. And what I mean is, maybe there's some sensitive information that needs to be taken care of. So there are certain risks that you need to be aware of. So architectural should also be able to address those risks and look at what the dependencies are. It should provide a good guidance. Architecture is essentially a framework for solving a problem. Architecture does not necessarily, it gives you guidelines, for example, to address a problem, but at the end of the day, you are going to have designers and developers that take that architecture and actually make into an executable solution. So a good architecture would be something that provides enough information, enough guidelines to build that particular solution. It should give you enough information. If it's too vague, it would not help with the designers and the developers to actually build something. If it is too specific, it will constrain the design, and there won't be any wiggle room. It's like drawing the blueprints, of any house. You provide some information, but I mean, again, that probably is not the best example, because in a building, the blueprint actually is very specific. But in the IT world, the architecture is more about giving guidelines, and where the designers actually and the developers actually put in a concrete implementation plan there. The next part about a good architecture would be, we need to recognize that you don't have only one audience. A developer looking at an architecture is looking for different kind of information as compared to a business owner. They are looking at a solution where a business owner is looking for how is my problem going to be functionally met? What are the systems that are going to come into play? How does the system interact with each other? And that's again at the business level. But if you look at the architecture, if a security or infosec personnel look at an architecture, They're looking at what are the security concerns, how should the data get encrypted, or where should the data get encrypted. If you look from an integration perspective, what are the forms of integration that needs to happen between two systems. So a lot of people have got different views or different things that they need to take away from the architecture, which also means that a good architecture should be able to provide multiple views and make sure that they're trying to address the concerns of different stakeholders. You cannot have all this information in one view. Can you imagine how complicated would that be? Trying to address security as well as business, as well as integration, and so on and so forth in one particular diagram. It's not only complicated, it's obviously people are gonna basically not use it effectively. So you should be able to provide multiple views for an architecture. This is one other piece of information that I'm gonna basically share with you. I don't think we expect you to use any of this framework, but you need to be aware of certain frameworks that are out there. These are the frameworks that basically give a guidelines on how to build an enterprise architecture. You've got Defense Department of Defense architecture framework, the DODAF. You've got Zachman framework, Gartner. Yeah, TOGAF is another one, which is basically used mostly where it talks about this whole circle of going through different things. And again, I'm not going to get into any of these details. All I'm trying to say is that there are different ways to approach this. There are different frameworks that help you think about architecture. So what are the building blocks of an architecture? There are essentially 4 components that we need to think about at the highest level. The topmost component is the business architecture. This comprises of business processes, organization, people. Essentially, it tells you, what does the business? It describes, what are the processes involved, what are the business functionality that are involved, what are the things that needs to be accomplished at a business level. The next layer in the stacks are application and data architecture. They are trying to address 2 different perspectives from an architecture point of view. One is from an application, and the other one is from the data. Again, all these have different views and different diagrams that can be represented from those perspectives. We are going to focus on the application architecture part today. So most of the information that you're going to receive is going to be concerned more about application. I believe you've already had a session some time back, which was about information architecture, and there were some discussion around what does data architecture mean, what are the components and what are the different diagrams that address that. Anyway, going down the stack here is the technology architecture. This is really where we talk about the software, the networking, the hardware that involves. Essentially talks about the different platforms, any physical components that are involved in it. So these are the stack. It goes from the business components to about how we are going to use our application, and talk about how the components are going to talk to each other, how they're going to interact, what are the components involved. To from a data architecture, is going to be about how the data moves, how do you manage that data, where the data is stored, what format it is stored, where do we need to keep it, so on and so forth. And then the last stack is the technology architecture. Okay, by this time you're thinking, wow, I think we are talking about basic stuff. This is overwhelming. We've got a lot of things here, business, application, and data. Where do we even start? And so let's think about how do we solve a problem. When you're presented with a problem, you are thinking about how at the highest level, what are the things that I need to address. I need to understand what the problem is about. I think that is the part that you already have gone through in a manner where you were given a problem statement. You looked at what are the requirements in that. You basically created the requirements document. Essentially, that's what you're trying to do. You're saying that here given this is what I think. I mean, of course, you went through those exercises, but in an organization, they would give you a requirement document, or you'd have a BA doing a business analyst doing the requirements gathering. But that is really telling you what is the problem, right? Once you have that, now you're trying to say, okay, what's a good way to solve this? As in, what are the components that I need to think about? What are the things that are going to play a part in this architecture? What are the constraints that I need to worry about? And this is again at a high level. So when we talk about constraints, you have to think about, what is my architecture framework? Am I to use this in cloud? Is it on-prem? What are the servers that I've got? Is it what database am I using? I mean, so these are again a small list of constraints. What I'm trying to say here is there are certain knowns. You know certain things about an architecture. You already have certain boundaries that you're already aware of. You know what a problem is. And essentially what you're trying to do is you say, okay, I'm going to start building this. I'm going to throw some ideas out there. And this is the beginning. So essentially what you're doing is you're conceptualizing it. And that's where we get to this conceptual architecture. Okay, so this is where we start talking about it. So before I move any further, I want to give an opportunity for everyone to, if you have any questions. And Shrikant, if you're here on the line, I probably need your help to unmute everyone. Okay, so I am not sure how to get this to work. So if you have any question, either raise your hand or shoot a chat to me, because I really don't know how to get this. I don't think I'm an admin on this. So let's see. So I've got a question from ZU. I just don't know. Can you send me a chat? Can you type it in your chat window, perhaps? Okay. Okay, if you have a question, raise your hand. I think Z has one. I'm going to unmute you and see. Z, you've raised your hand, so I've unmuted you. Can you ask a question, or it's by mistake?
What?
Oh, you had your hand up.
I have a small question.
Yes.
I have a small question about application architecture and the data architecture. So we can do it at the same time, or it has some process to do which one at first?
Oh, that's a great question. So the question is, should you do data or application architecture? Those are, yeah. So essentially, one is dependent on the other. But one is not. I mean, so what I mean to say, I guess, is you don't necessarily have to complete one to do the other. Though there's a dependency amongst each other, you essentially start with building some application architecture, and then you soon realize once you go to the couple of steps, and I have some information about it later in my slide deck. But once you go past certain point, you'd realize, okay, now I got to think about how the data is going to flow through this. That's where the data architecture comes in. So it is not completely dependent on each other, or you don't have to finish the application architecture to start the other one. You can start it somewhere. Once you get a lead start in application architecture, then you start thinking about data architecture as well. Does that make sense?
Yeah. Thank you.
Okay. Looks like Ben, you have a question here, and I can't unmute you for some reason. Oh, there you go. Okay, Ben, you're
Okay.
unmuted.
The question is also regarding the order of to develop the business, to develop the application architecture and the data architecture. So do you think it is a good idea to develop start with the application architecture, and in the process, like I mark some data in the diagram, and afterwards I extract the data and create the data detector.
That is actually correct. I mean, that is exactly how you'd approach it. You would start with an application architecture to get a sense of what are the components involved, how is one going to interact with the other. Once you get past that step, the next one is going to be, okay, well, now that I know how these components are going to interact, I got to now start looking at how the data is going to start flowing through it. At that point, you're going to start building on the data model and look at the data architecture. So you're right. It starts with an application, and while you're working on the application architecture, start building the data architecture.
Okay, thank you.
All right. So I don't see any more hands. I'm assuming either you guys have fallen asleep or everything is just going perfect. Z, your hand again is up again. So, okay, Z, you're back up here.
But I don't have more
Oh,
questions.
I'm sorry. You had your hand raised, so I thought you had a question.
Sorry.
That's
Sorry.
okay. That's all right. All right. So moving on. So what is a conceptual architecture, right? I mean, now you've got a point where you're saying, okay, I know what my requirements are. I'm going to start put something together. Just kind of draw that broad stroke picture, just to kind of see, put the blocks together. So a conceptual architecture essentially is a mechanism to capture your ideas. You're saying, I know if I'm going to, work on this particular application, I have a sense of what other applications I need. For example, I need data from membership, or I need something else. I need to, interact with this other system. Essentially, you're just trying to put those blocks together. You're saying, and that essentially has, entities, objects, what the relationships are, and so on and so forth. Okay. The whole idea about doing the conceptual architecture is to kind of figure out how are you going to solve the functional problem. It is, I think it was like it was asked by Ben, it's not about, how is this going to work end to end. So you don't think about the data flow or the process at this point. All you're thinking about is, if I have to solve this problem, and my next slide has an example, but essentially saying, if I have to solve this particular problem, what are the different things that this particular system is going to interact with? What is the information that the system is going to need to be able to solve this, right? It's not about the flow yet. Okay, it's basically looking at, here it says about a domain level responsibility. What it means is, say for example, I need to get a tax calculation. So tax calculation is in an application by itself. Say for example, so you're going to say, this particular new solution of mine needs to work with this tax application, and that domain level responsibility is drawn into a block. That gives you a good sense of, what is the size of this, what are the different things that I need to consider, whom do I need to go and talk. Oh, by the way, one quick thing, if you guys have any question in between, don't wait for me to pause, just raise your hand and I'll pause it at a good logical time and give you an opportunity. So so conceptual architecture is about, putting all those ideas on a page, essentially. Now, the one thing you have to remember when you're doing this is, think about this last statement, there is address the architectural significant requirements. What that really means is, what is it besides the functional thing that I need to think about? If, for example, a particular application is about, where the user needs a response time, a fast response time, that's your architectural significant requirement. And then we'll get into the whole NFR conversation, which is a non-functional requirement. non-functional requirements, but right now keep that at the back of your mind. So you have to try to think about, I'm going to do, this is my biggest thing is, for example, one other example could be this application just cannot fail. It needs to be redundant. So redundancy is one of your things you have to think about. Does that necessarily get stated in the conceptual architecture? Not necessarily, but there could be some architectural significant things you have to kind of think about when you start putting the conceptual architecture together. Ben, you had a question here. Okay, there you go.
Can you hear me?
Yeah, I can.
So this is regarding the second bullet here, seeing the diagram that captures entities, objects, this one. Are you talking about the ER diagram here?
I'm sorry, can you repeat that? Am I talking about what?
The ER, the diagram about the entity and the relationship.
No, I'm not talking about the ER diagram. The ER diagram is in the context of data. This is, I think it's in the general sense, entities and objects are basically things. Things that I need to think about. And my next slide will talk about what exactly when I say those objects. But I'm not referring to ER.
Okay, can you please tell me a little bit more about the difference between the business architecture and the application architecture? Because the second item seems like business architecture.
Okay.
Business processes, right?
Okay. Well, so the business architecture is really at the highest level of how a business functions. So it is about what the business processes are. It is about what the business does. For example, if a business has an accounting system, account payable system, and it needs to pay the vendors, that's a business function. So that's, and at the highest level, it is capturing a business process saying that, payment, AP payment needs to be made put up to a vendor. That is, basically where your business is going to ask your question, about, this is a particular functionality that I need to fulfill to the business. Application architecture is then about what is the application that I need to put in place so that I can fulfill that business architecture. Is that making sense?
Well, yeah, it sounds, so the conceptual architecture is like more detailed than the business, right?
So it is, yes, it is more detailed in the application world, in the IT world. Business business architecture is in the business world. So let's how about we get to that next slide, and maybe that will give you an example of what the conceptual architectures are.
Sure. Thank you.
Okay, so this is really, so one of the diagrams, so about to capture a conceptual architecture is context diagram. And this is really what I was talking about with this entity, objects, and relationship. Here, as you, for example, we are talking about this OMS system. It's an order management system. So, for example, when you buy something online, this is the system that's actually going to process your order. And if you are trying to design, or if you're trying to architect an order management system, there are several things that it needs to talk to. It needs to connect with. For example, if you're taking an order, well, you need to be able to process a credit card, for which you need to work with this credit card application, which does your credit card validation. So as you can tell, the OMS system has got a uses. It defines a relationship and the component that it needs to work with. So this is, so when you're trying to kind of put an architecture together, and you're wondering, okay, where should I even start? This is that starting place where you're saying, these are all the other systems that I need to think about where the OMS is going to interact. For example, you've got master data management, or you've got the fulfillment system. And as you can tell, the dependency, and this is a general way of representing, you have an oval, which is a system into consideration, and then you have got rectangle systems, which it interacts with. The relationships are usually specified at the connectors. So you can tell that an OMS system dispatches, to the billing system. I mean, this is basically giving an idea of how this particular architecture is gonna be in the bigger scheme of things. This is typically non-technical in nature, in a manner where your business uh, entity is gonna look at this architecture. They're gonna basically think about this as a view of how a particular application is going to behave. Um, it, as you can tell, it has got relationship with other system. It is calling out the relationship, and it is easily understood by the business. I think Nirdesh has a question here. You're unmuted, Nirdesh. Go ahead.
So, in other words, are we saying this context diagram is essentially we are identifying the system of records for, let's say, a particular data entity, or let's say a, a conceptual architectural context and how the systems are related to each other?
That is correct. I'm just going to pick on one term that you said about data entity. And the reason I'm picking it is, the first notion that comes to mind is, what is the data I'm going to use from the other systems? But that's not what this is about. This is about, and I don't necessarily think that you're saying that, but I'm just making sure that we understand it. What this says that, credit card validation system is another system this thing is going to work with. Is that making sense?
Yes, and I think, yeah, we are on the same page. Got it.
Okay, perfect. So we have got, so this is basically the context. This is usually the first step when you start building an architecture. This sets the context of what your application is. It gives you an understanding of, what are the system it needs to interact. This is where you start building the picture. This is you're saying, okay, well, I got to involve all these people. I mean, again, I'm talking from an industry perspective, but I've got to involve all these people. These are the people because this is the system I'm going to interact with. I need to understand what my interfaces are. If it's a credit card validation, then is it going to be a web service? If it's a web service, is it a REST or a SOAP, so on and so forth. But this gives you a picture of, who are the parties that I need to work with. Okay. Once you put the context diagram together, then comes the next one, which is, and again, for this particular competition, what we have done is we have selected a few views and diagrams, for you guys to have, and I'm going to talk only about those because in reality, there's a lot more to it. What we want to do is make sure you get enough to understand about architecture. It should not overwhelm you, but at the same time build something substantial. So basically you're picking a couple of diagrams that you're going to work with, but don't think about this are the only things that you do. These are essentially some few of the diagrams that would help you build your solution. Okay. So the next one is a logical view. Now the first thing that you saw, what all the components are involved, right? I mean, it tells you about what system I need to interact. But this one is particularly is talking about what are the things architecturally that I need to worry about. In other words, for example, as you see in this diagram, this particular organization has an n-tier setup. You cannot really jump from an access layer directly into a data layer or an application layer. You have to go through certain layers. These are the things you have to kind of think about when you're putting. So the logical view actually gives you a logical way of how the problem needs to be represented. It takes the functional requirement into consideration, but then it also thinks about what are my architectural things that I have to think about. Essentially, it basically gets to that next level of details with building your architecture. Okay, I'm going to pause here again to make sure if you have any questions, anything that you need to talk about before I move on. Raise your hand. Don't be shy. Wow, I must be doing good. Or you can't hear me, either one of that. Okay, all right. Let's move on then. So now that we have done with this whole conceptual architecture thing, this is basically building the concept. Now we are getting into the actual, the other part of it, which is the software architecture. I put in a definition of this, so that you can understand what does it really mean. It is now getting to that next level of things that we're talking about. We already talked about, what a context diagram is, and then what a logical this is. Now we are talking about, okay, now that we have those, let's talk about the next level of details, which is I am, for example, I mean, I can read the definition, but so can you. So rather than just reading it out, all it is saying is, let me see what are the components involved. Let me see what are the interfaces involved. Let me see how they're going to talk with each other. Is it going to be synchronous or asynchronous calls? I mean, all the things that are now going to matter are the ones that you're going to start capturing in your software architecture. Essentially, it's architecture of the software system, as it says here, where you're basically putting a structure around all the significant components and how they're interacting with each other. Okay, so why do we even bother? Why do we even do this software architecture? Well, this is really getting to understand what are we dealing with a given solution. It is basically defining what the high level components are, but also representing the architectural styles, like what you saw there in the layered architecture. Essentially, you're trying to kind of say if they're connectors, what patterns we should use. All in all, it's trying to address the non-functional quality attributes. Now let's pause and talk about what non-functional quality attributes are. Functional attributes are something that a business asks for. This is the purpose of the whole thing, right? I mean, you're doing all this stuff so that you can solve a particular business problem. Those are your functional requirements. Payment system need to be able to accept credit card. It needs to be able to process it. It needs to be able to charge it, and then we need to be able to make an entry in the ledger. Okay, perfect. So that's a functional requirement. The question could be, okay, when it comes to the non-functional requirement, you start asking the question, okay, well, does it need to be scalable? What happens if on Christmas Day you've got 5 times the traffic? How are you going to think about that? What should be the response time? Is it okay for the user to sit for 5 seconds for them to get a confirmation, or it's a bad user experience? So, and oh, by the way, is the data secure? If I'm going to take credit card information, am I building the system so that none of that information is available in the clear? So those are the things that the business don't necessarily tell you. They don't tell you that as a functional requirements. They basically tell you as to what are the functionality that they need from an application. But these are the ones that you have to think as an architect. You have to think about what are the stuff that they don't ask, what are the stuff that they are not telling me directly. This is usually which is very tricky. And essentially, in my mind, architecture is all about non-functional quality attributes. Sure, you're going to solve a problem, but I think you could solve the problem anyway. The bigger thing or a good architecture should really address is all these non-functional quality attributes. As I think I heard this somewhere. A good architecture is like a good building, right? I mean, when you walk into a building, every time you walk in and the building doesn't fall, that actually is a good architecture. Nobody really pays attention to building architecture until it falls down. So what we are talking about is all these non-functional quality attributes, which is really essentially the foundation and the pillar structure of the building that really nobody asks you when you go looking for a house. They're talking about, what's the size of the room you need? Can I have access? I need 2 bathrooms. Those are the functional. That is something that you need to do. But the real quality of a good architecture is all this stuff that is non-functional and will support a particular solution. Does that make sense? Do you have any question about this? Ben, I think you have self-muted, so I can't. Oh, there you go. All right, go ahead, Ben.
Excuse me. Could you please go to the conceptual architecture diagram?
Conceptual architecture diagram.
Yeah, previous one. Previous.
Okay.
Yeah, this one. So
okay.
This diagram, I see some layers here, but I'm not quite sure about the the definition of the access layer and the presentation layer and the application layer. Those 3 layers. Can you please explain?
Of course. So what I guess I'm trying to tell you in this particular diagram is um, sometimes organizations have built this n-tier architecture. What that n-tier architecture means, and I can go through this particular one, is, for example, if a web application needs to do something, right? It needs to, for example, we're talking about a payment system that needs to be done, or the OMS system. There's an application logic, there are application servers, but when you're coming from the UI, when a user is interacting through it, it essentially has to go through a particular layer to get to the application logic. I'll explain you further. When a web browser makes a request for a particular functionality, you got to make sure that a particular user function or user login or user session is maintained, so that when the user comes in for the next request, you don't ask again, where were you? You basically need to remember the state of that user. That's what handled by a presentation layer. So basically, there is a logic in between before you get to application, which handles how the UI looks, what are the user session management, and the sum of all this is that you move through these different layers to be able to do your work. Architecturally, these are significant because when you write an application level layer function, you can't really write that in a presentation. You can't, or you cannot have a presentation layer essentially make a direct entry into a data layer. And these are the things from an architectural perspective. These are the things, that you need to think about when the developer needs to kind of think about, I'm going to write an application logic. If the application layer tier is defined, they are required to write that logic in that particular layer rather than somewhere else, so that you maintain, the security, the separation of concerns, so on and so forth.
So these are the conceptual layers. I mean, if we use some software, maybe it can serve like one or more than one layers, right? For example, for some web server, if we go to the technical stack.
If you look for example, from a web server, right? So the web server will probably be your access layer. Your presentation layer. Your web server takes all the requests and maybe maintains a session for that user. Your application layer is going to be like a web sphere or a web logic application server. They also maintain their state, but it's at the application layer. So if you talk about a software in general, they probably have their own architecture. But this is probably going to be a software example where an organization has different layers defined to write their own software. It's not, I mean, if I understand you right, that you buy a ready-made package. Is that the thing in here? Well, they're probably going to be having the layers within the package. But this happens when you are trying to define and develop this application yourself.
Okay, clear. Thank you.
Okay, so okay, so let's go to the example of what a software architecture would look like. Okay, I've put an example here. I've just drawn, and again, this is really something that we put together. This is not a real application. What essentially it is talking about is some application that has got multiple ways to access. You can have an external user portal. You could have, you could use a mobile, app. You've got a vendor portal, which means it's another type of external user. Then you have internal user that needs to access this particular application. Again, the kind of application doesn't really matter. All I'm saying is there are different kind of users that are coming in. Then when they come in, obviously you don't let them in directly. You have a firewall. You have some security that you obviously need to think about. When the users come in, they need to log on to the system. So ADFS is essentially that security layer. And again, not getting into into details of what the ADFS or anything means, but essentially, it is something that authenticates a user and makes sure they have access to the system. And then you've got the web server. You've got Apache as your web server that that the users first interact with. Then you've got WebSphere as your application server. The WebSphere, once whatever the application does, it writes to an Oracle database. As you can see that there is a line running from the WebSphere into the AD. Essentially, what that means is it's maintaining a security context so that the web application server can keep a track of who can get in at another layer of security there. There's an enterprise bus, which is really an MQ, some kind of place where you can put messages. I'm using MQ as an example here. And there are the other enterprise systems that are going to consume whatever messages that you throw on the bus, right? I mean, so I'm just kind of presenting, this is just painting a picture of what a software architecture would mean. This is great. Now, I'm just going to highlight a few things here, okay? Like you see, this particular architecture is going to talk about multiple interfaces. Even if it is a vendor portal versus a mobile application, the UI is going to be different because they are different forms. So you'll have a different kind of users coming in. You also notice that the internal portal is not coming through the firewall because you're going to have users coming from inside the network. You don't necessarily need to authenticate them. That brings the next thing, which is the security. So what is represented is, how do you represent security? You have got a firewall that essentially, everybody needs to authenticate, for which again they're going to use ADFS. Every user is going to get a security token. That user is going to get authenticated against an Active Directory where you have users. Like I mentioned earlier, there is a security context that is that the app server maintains with the Active Directory. So essentially, this is covering the security part of it. As you also notice that there was no reason to call out two web servers, but what it is saying is to be able to handle load, I need to have, for load balancing, I need to have multiple web servers. I've also showed some cluster of app servers here. What it means is, when the load gets more, you need to be able to handle it. One way to do it is have a cluster of those. And lastly, it also talks about the kind of communication. It says I need to be able to put the stuff on the MQ series, but it's an asynchronous. I can fire and forget. That's essentially why I use a bus anyway. It'd say I'm going to put a message and don't worry about it. I don't want to make sure. I don't want necessarily need a confirmation from the enterprise system. What this particular diagram is trying to convey is when you present a problem, you could have just had a particular user interface essentially going to a web server and going to an app server, and that's about it. All this other stuff that is represented in the diagram is trying to understand, or and that's actually addressing your functional requirements, right? But all these other things that we are trying to show here in this are addressing the non-functional requirements. They're basically talking about all the stuff that needs to happen outside the functional requirements in order to support the solution. Is that making sense? So this is really, the gist of what a software architecture is going to look like. When you think about putting your own version of software architecture, make sure that you call out what are the architectural constraints that you need to work with, what are the non-functional requirements that you're going to try and address, and the most important thing that really is not everybody's favorite is documentation. I mean, it says, it's like, well, a picture is worth 1,000 words. Yeah, sure. However, especially in architecture world, if you don't have an explanation for what that picture means, then everybody is going to basically derive information from that picture based on how they perceive it, right? Architecture is no different. You put an architecture diagram together. You don't put in any appropriate documentation. You know what? Not only is it incomplete, so that people won't know what you are trying to tell them, but worse yet, people are going to derive a wrong information out of it. So, for example, in our previous one, in the previous diagram, I don't know if you guys notice it, but there was a red line here. I mean, so the others are black, and then there is red, but there's a dotted line. And some of the, and this is intentional. I mean, it's not because I just felt like, we can change the color of this, this has got an indication, except, and I've done this here already, I didn't tell you what it means, right? So one is, you might or might not notice it. Two is, I'm not presenting the information that I need to present. I probably meant to say that this red means, it's a communication with an Active Directory, or security, whatever I'm trying to say. The essential thing is, any information that you provide without telling what it means is gonna be not going to be useful or the user, and maybe they might end up deriving a wrong information from all that. Okay, so this is good. I want to pause again here for a minute to make sure that if you have any question, and I think Ben, you've raised your hand, and I'm going to try and unmute you. Okay, there you go.
Okay, so question is regarding, do you have any recommended tools to draw the diagram other than Microsoft Visual?
I personally, for the competition, no, there isn't. I don't think we are requiring you to use any particular tool or any format. I mean, I don't think we're requiring you for a UML format or anything, as long as you explain what you have drawn.
Okay, but I mean, eventually we need to use some software to draw the diagram. Do you have any recommended software or web tools, web application?
Visual just works fine. Google Doc has got some built-in tools. That should suffice for the work that you're doing. That should just be good enough.
Okay. Okay. Thank you.
Okay. Any other questions? All right, Z.
I have one question about the user interface. When we consider about the user interface, we need to consider the different devices, or use responsive design, or we can just design one specific like a mobile app.
If you are considering a particular web interface that you're going to access from the desktop as well as mobile, I think it is important for you to also consider, if it's going to be responsive or not, because you're not going to show the same exact page on the mobile device which you're going to show on the desktop.
Okay.
That is one of your architectural constraint or consideration.
Okay. Thank you.
No problem. Bin, do you still have a question, or you just forgot to take the hands up? You still have your hand up. Okay.
Yeah, so no question. Sorry.
Okay, that's okay. All right, just making sure. All right, so this is all fine and dandy, but how do you want to? Oh my God, this is messed up. Okay, how do we use all this information? And excuse this whole arrows of mine. I think I probably messed up the UI here. But what I was trying to convey is how this whole thing, whatever work you're doing, is going to progress. Essentially, you've got your business requirements and your business architecture that you've started. Basically, it's your business requirement. I don't think you've gone through the business architecture race, but you've started capturing all your business requirements. Once you have those in place, then you're going to start identifying, what are my main components and what are the relationship that I need to start thinking about, and as you saw, once you have that, you're going to get to this part where you're going to create a context diagram. And I think somebody had asked me already, should we do the data modeling or should we do the application architecture? Like you can see here, your context diagram is really going to be a point where you're going to start thinking about, how my data is going to start moving. That's really the time that you're going to start thinking of creating your conceptual and your logical data model. And this is trying to address the data part of it, right? While once you have your context diagram in page, then you're going to say, okay, what are my boundaries? What are the constraints and patterns that I need to think about? What is the information that I know about the organization and about my architecture that's going to constrain me to build my solution? Once you start identifying them, that's where you're going to capture in your logical view. And once you have all this in place, then you get to the last part of it, which is your software architecture, because now you know what your constraints are, you know what your components are. The last thing you're going to start looking at is, how are my non-functional requirements going to be captured, and how you're going to detail out. On the data side, and I'm not going to get into the specifics of the data side because I think that was covered in the information architecture part of it. But that's again a logical view. Once you start thinking from a context part of it, I've got my context diagram defined. I know what components are going to play a part in it. Now you got to start thinking about what is going to be my conceptual data model. And once you have your conceptual data model, you can start looking at creating your logical data model. There is the next step of it. I haven't listed it here, which is a physical data model, as you probably heard from Shekhar the other day. That gets you into that next level of detailing as far as data is concerned. But these are the two flows that are that's going to happen and going to become a part of your deliverable. So what's going to happen is you're going to get some kind of templates. I think Shrikant or Rakesh is going to send out those templates, and those are going to talk about what are the diagrams, or what are the views that needs to be submitted as a part of your deliverables. And essentially, this is a way of what basically we talked about is, what does those view mean? The template is going to provide some more detail as to what you need to capture, and what is the information that needs to be submitted as a part of your submission. So that is essentially what I had for this particular presentation. I've got a list of things here, and I think they're going to share this slide deck, but essentially it talks about more definitions. It gives you more information about all the views and architecture. My hope was to kind of complete this in an hour's time, which I have, it looks like, and so that I give you some time to go back and ask some questions specific maybe to what you're thinking about, and just maybe take some time to kind of absorb this information. Obviously you can reach out to anyone of us and ask them ask a question about it, but I've got this other next 30 minutes left for us to for you guys to ask any questions. So do you have any? Okay. It doesn't look like there are any questions here. Oh, Ben has one. Okay. All right. There you go, Ben.
The question regarding the non-functional aspects of the design. I mean, as an architect, normally you need to think about something like the response time, and it's like less than 1 second or 3 seconds, or it's like how the application will adapt when the concurrent users increase rapidly, like on Christmas Day. So I mean, like how can I get the clue, like how I can have the estimated time and how many servers I need?
That's an excellent question. So if I could rephrase that, what you're saying is, if I want to create this non-functional requirement, especially with the response time, what are my starting point? How do I even know what my response time is going to be? and that's a fair thing, because until you actually test it, you wouldn't know. Performance testing is one way to find that out. Excuse me. But while you're building the architecture, obviously you're you're right at the beginning of this process. So the usual way to do it is there are benchmarks. When you look at when you server, when you look at networks, they provide some kind of benchmarks. They say that if you're going to travel this distance, this is the latency you're going to have. If you're going to use this CPU, this is basically how much time it's going to take to process. And you can start with some of the benchmark and estimate as to, this is where we're going to have, so many CPUs and whatever or memory to be able to address this, this response time. But the reality is, once you put something together, and again, for your architectural, can you assume, make some assumptions. You're going to say, I'm going to assume that this is going to be my response time for a particular server, and the distance I'm using for networking. Hence, I'm going to use 3 servers so that I can support this. In reality, you would actually, propose that, and then you'll have to do some performance testing and doing some benchmarking yourself, because every environment is different. Your server can tell you, whatever it is they are when you actually buy them, but when you use it in your ecosystem, those benchmarks could be way different than what they provide for the manufacturer tells you.
Okay, and another question is, how about the cost?
Cost again is, now in the world of VMs, it's become a lot more easier to estimate that. Earlier, you would probably have to go, if you're building your own farm of servers, then you have to go find out, what does the server cost? If it's IBM, what it's going to cost, and how should I plan for that? But if you're thinking about, I'm going to use AWS, I'm going to use the server, then you really know how much, basically it gives you the costing that for this particular workload, it's going to cost you so many dollars per hour or per day or whatnot. So costing, again, we are expecting you to give us an estimate of the costing. And I don't know what a template has, I guess, but if you're providing any costing information, it's important for you to state your assumptions. I think that's super important, because anything that you say might or might not be right. But if you make an assumption saying that I'm assuming based on this costing, I'm assuming I'm going to use so much, hence this is what it adds up to. So then that's actually a fair way to suggest what your cost is.
Okay, so you are saying that the cost estimation is part of the application architecture design, and we need to make a reasonable assumption and stick with it, right?
I don't know if it's necessarily a part of the application architecture design. I think it's a part of your whole architecture. When you provide a particular solution, costing is a part of the solution per se. A lot of organizations do it differently. Some organizations require the architects to also provide the costing. Some organizations don't. For our solution, I think it's architecture is a part of how you do it. Costing is a separate section of a solution. And if at all you're going to do costing as a part of your solution, then make sure, like I said, that you state what the assumptions are.
Okay, thank you. No more questions.
Okay, no problem. Are there any other questions that you need to ask? Okay. Well, I can hear cricket, so I'm assuming that we're fine here. Shrikant, are you on the line by any chance? He just got back from India, so he's probably not. Okay. Well, I guess this is all I have for today's presentation. If you don't have any question, we can wrap up here. I think we still have our email addresses, so feel free to reach out to us if you have any questions. We are available, I guess, to respond to that. And that's about it. So have a good night, folks, and all the very best with the architectural work. I think you are onto something yet. I'm sure this is going to be really helpful for you. All right. Bye for now.